Hi friends, I'm Vinay Krishna from Pingala Software, and it's a technology startup based in Bangalore. We are working in cutting edge technologies such as blockchain, IoT, AI, ML, cloud agnostic solutions, DevOps, and so on. So, welcome all of you. And today's webinar topic is software delivery using test driven development. Today we have with us Lance, and we also have with us Sunil. So Lance is a very good friend of mine, and we have worked together in one of large CD transformation, I guess 2014-15. And
That's
he's a
right.
very sound technical coach, right? Uh, he is passionate about agile practices, engineering practices, love to work with the teams and mentor them on lots of engineering practices. One of them is like today we are going to talk about test-driven development. And he also works with the management team, leadership team, and pointing out them that what are the problems there so that they should be able to understand and bridge that gap. So he is actually a kind of coach the management in servant leadership also. And one more thing which I want to highlight here, he is a science fiction published author as well. So he writes, and lots of time you will be able to see that. So he is coming up with something new on that topic. Uh, so that's how he is. Uh, I'm not having much idea or much information about Sunil, but yes, of course, Lance, if you can just introduce him, that will be good.
Yeah, Sunil's the secret weapon. So Sunil and I worked together on a large transformation over in the States that was in was when 2 time zones in the U.S. and also included sites in Pune and Hyderabad and maybe is that it, Sunil? Was there one more site in India?
Bangalore.
Bangalore was there too. So he was really valuable in order for me to be actually helping teams on hands-on coding. He was key in working with directors and management and helping do the coordination work that needs to happen in order to do a large organizational transformation.
Okay,
Yeah, thanks,
so
Lance.
I will just tell you, yeah, I will just tell you that what will be the format. There will be like a 45 minutes. We will be discussing on that TDD topic, right? And there will be some simple question, right? And there will be some difficult answer also, right? To digest. So you have to make sure that how it can become a very simple answer to the audience. And 15 minutes we will be keeping it for the audience where they will be posting their questions in the chat window, and we will be just reading out for them, and you guys can answer at any point of time. Yeah.
Okay, cool.
Okay, so are we ready?
Yes.
So, Lance,
Okay.
you want to bring up
So
the slide deck?
Yeah. So, okay, I'm going to start presenting then, Vinay. Let's see. Now I got
To share your.
yeah, I'm looking into that.
So yeah, so as Lance brings up the slide deck, I just wanted to, so I and Lance have been working for the last 4 or 5 years, and that is where we saw. So I'm a TDD evangelist. I have really seen the benefits, and I have helped, and I am a agile coach and a Scrum Master, and I've been working with leadership in helping adopt, and that is where we have seen as to the benefits which TDD can bring, and that is how TDD Gurus was formed, was born, and so today we are going to cover uh, broadly what TDD is, how does it help teams improve code quality, manual testing versus test automation, TDD, how TDD helps reduce development cost, and also how teams can adopt and help on work on legacy code. So we're going to cover that. We also want to cover a little bit around TDD adoption itself, because as important as practice is, we have realized that you know adopting and having a proper ecosystem for TDD adoption is equally important, because if you cannot let TDD the practice foster, then the practice itself will suffer. So that is why we'll talk very briefly about how we can successfully adopt the practice of TDD also, right? So Lance, the deck, are you able to bring
Yeah,
it up?
just 1 second here. I'm going to drop and then re-enter. That's going to be required to give this permission, it looks like. So let me see. First, let me see if I got it. Oh, maybe I don't have to. Yay.
All right, just waiting. All right.
Okay. Oops. Sorry.
Yeah. So let's go to, we're past the agenda.
Okay, let
We
me
can
get
move
this.
to slide number 4.
Okay. There's us. Those handsome people all in black, by the way. Very nice.
So we have
So
crossed the
pass.
agenda itself.
Okay.
We passed the agenda. So next one after that. Yeah. So, time to market has reduced and complexity of products has increased, right? So we organizations continuously want to be as fast to market as possible, while they want to, de deliver complex products and applications and complex features, right? Next slide. So, and because of this, because we are looking at, you know, delivering faster and more complex products, we want, and we have found that, that teams want to, or organizations want their teams to spend at least 75% of the time on delivering new features and not having to continuously work on, or bug fixes or rework, right? So this is where TDD comes in most helpful. Right? That it can help develop quality code, and that will, in that way, help teams deliver features faster without having to spend too much time on the rework and bug fixes. Right? And then Lance, we can go to slide 7. Next one. So these are the 5 top challenges which we have seen for software teams which they're working on, and this is where we see that TDD can help, right? So top priority, and you are all professionals, you all have seen. So managing the bug inventory is a very high priority. Using development resources to do bug fixes, and how much time are we spending on bug fixes? Uh, even though we write and develop this, suite of tests, they are not effectively written, and then they're not effectively executed, and so they often lose their importance. Now, time spent on maintaining and ignoring ineffective test automation, that also is a challenge right now, which teams are spending on. And because of all these issues, development is deployment is slow, expensive, and often because of this, we have a lot of fallouts, we have a lot of escape defects, and that again impacts code quality, it impacts development time, and it costs for the company. So what we have seen is technology has pretty much caught up with business. If before business was leading and technology was following, now it has changed, right? We are in parallel. So we find that business often does not know what they're looking to build. It is from that context that because we want to be effective partners, we want to make sure that we are writing effective code and delivering high quality so that business can focus on actually what they're looking for, right? So this is where we see how TDD can help play a role, and how being able to know how to effectively practice TDD will be helpful. So with that, I will let Lance take over. Lance, and if you can
Yep.
talk more about that.
Yeah. So those on the call, I'm assuming that you've seen some test automation and maybe you weren't happy with it. I'm also assuming those on the call maybe have bug tracking systems that are tracking lots of bugs and they're not set to 0, meaning you shouldn't need a bug tracking system. You should have, You should have zero bug count, and I've seen that happen on multiple projects. So how we did that on multiple projects, we've driven the bug count to 0 or really close. Maybe we had a few hundred, but after a year, the number was in the dozens. So we did that by adding test automation. That was effective. And one type of test automation is was created with test-driven development. So when we say test-driven development, we usually mean unit tests, or also called micro tests. Those are tests that are designed to test just one function or a method of a class to confirm that it's working as the developer designed it. And at the beginning, when we start doing TDD, is we want to test our test. We write when we add oh, somebody needs to mute, please. So when we want to add new functionality, you do it just as you would today, is you identify where you need to make this code change. And you identify what function and maybe what line you want to change in the function. And at that point, that's where TDD starts. You write a test that tests that function, and you do this before you even change the code. So you write test code before you change the product code. And you then run the test and observe that it turns red, that the test will fail, because you want to prove to yourself that the test can fail, that it's that's a test that can function as a failing test as well. Okay, once we get a red state, then we want to add the code that was the reason we want to add our new functionality into the code. So you make the adjustment as you would when you skipped TDD, you would just make the adjustment. So first we wrote the unit test, and now we're going to make the adjustment, and we're going to execute the test, and now the test will report green if we've done it well. If it doesn't report green, we have to work that out and either adjust our test or adjust our code. Now, once we have the test reporting green, we can do another topic, which is called refactoring, where we're going to improve the design, because maybe there's some issue with the code, maybe it isn't well crafted, maybe it's messy. And now that we have a unit test, we can confirm after we refactor the code that it stays green. That way we don't check in bugs. So TDD forces us to be better developers. TDD forces us to keep our methods or functions small and easy to test. Big methods are really hard to test. And methods that call many other methods are also hard to test. So one of the things when you do TDD is that it makes it hard to write bad code because it's hard to test bad code. The code maintenance is the largest cost of software development. It isn't code creation. And the code maintenance is easier to do because you can make changes in the code that improve the design and then run the tests. And within minutes, you can find out if the tests still pass. And if the tests still pass, you're happy. Wow, I've improved the design and didn't add a bug. That's awesome. It also allows for tight team collaboration. A couple of ways it does this is that the automated tests document. So when I'm writing code and I add automated tests, the tests themselves document the effort that code should be able to do. And when Sunil then looks at the code the next day, he will also not only see the product code, which is the code that gives us the functionality, he'll also see the test code, which is confirming that the product code is working correctly. And he'll have a better understanding of what my intent was. Excuse me. Or we could even pair program together, and maybe Sunil is a very skilled unit tester and doesn't know the business domain well. And maybe I've worked on this project for years and I know the business domain well. I know where all the parts of the code are to get things done. And so working together, Sunil and I can pair program. Sunil can write the test, I can write the code, and we're both, excuse me, very happy. And then we could switch roles. I'll write the test, he writes the code, and that way we have to, by collaborating together, we both make one better super developer. Yes, we want to make super developers. And of course, the whole point is to prevent bugs, because it's like this. If a test is failing, you're not going to check the code in, I hope, right? If a test is failing, it's telling you something. It's informing you that, hey, there's a problem, come look at this. And when you go look at it and figure out, excuse me, you figure out what the problem is, you correct it, and then you can, when the tests all pass, then you know it's okay to check the code in. So we can do quick changes because unit tests, when built correctly, don't have high maintenance costs and they execute within minutes. So this graph shows climbing functionality. We like to be able to jump all the way up here and have lots and lots of functionality that works correctly. So this is correctly working functionality. So without TDD, if you're doing manual test passes to confirm your functionality works, it's a lot of effort. So you add some functionality, some people test it, and oops, oh, something didn't quite work. So we have a regression. Okay, well, the developers work on the code, we add more functionality, we fix the problems, the quality overall is higher, and then whoops, oh, a little bit of a bump. And as the code base grows and we add more and more functionality, as the number of lines of code increase, the problem is when there'll be a point where we want to add more functionality, but it will cause a big drop. And that drop happens with lots of bugs, happens because our design isn't very sustainable. It needs to be refactored. And without automated tests, it's very hard to refactor code. Developers are reluctant to change code unless they have unit tests that tell them everything's still okay. Nobody wants their manager to say, hey, we have these bugs, what happened? And you say, oh, I improved the design. The manager usually gets kind of upset. He goes, well, why did you change the design? Now we have bugs. I think I like the old design. Maybe it wasn't very nice, but I didn't have bugs. So you see, if we have unit tests, we can only increase our functionality and we don't have these big drops. So some benefits to TDD. There's lots of benefits. That's why the slide's very busy. Every time you add a unit test, you're increasing your regression suite, which means we'll have more confidence that there's no bugs. The biggest result of TDD is that you don't have to spend so much time fixing bugs. In my career, I've been doing software development since 1995, have almost never been part of a maintenance team. That means I only work on teams that add features, and occasionally we have to fix bugs, but rarely. So that none of the projects I've worked on required a maintenance team. It didn't require a large number of people to support it. It just required the development team that adds new features, because we had 0 bug releases frequently. Sometimes we have 1 bug. 1 bug's easy to fix. So we didn't have to spend much time with debugging. We did spend time writing automated tests. We got better code quality because you can improve the design and conveniently find out if the tests are all going to pass. So there's lots of reasons you should love doing TDD, but it requires a change. It requires a change because even in college, we were trained to write a small program, pass the homework assignment or pass the exam, and then we move on. What college didn't prepare us for is maintaining code. So that code we wrote when we were a freshman, sophomore in college, we never had to maintain it over years. But in the industry, software systems are around for more than 10, 20, 30 years. They can be around for 50 years. So Java, for example, is over 20 years old. So these systems are going to be around a long time. So we need to design our systems so that they're maintainable over a long time. Okay, I'm going to play a short video. I need to adjust the audio setup here a little bit. Okay, so it's going to be a little bit more hissy here. And let's go. Oops, one moment. I'm going to have to get the audio. Sorry, it'll take me a second here. Okay. One moment, I'm getting the audio still not working. Well, I think I'm going to do the voiceover here. All right. So what we have happening here, I'm going to do the voiceover, is we're writing a system model of quality. And as we add more tests, we are delivering, as we add more manual tests, we're improving our quality. But the problem with manual testing is that the effort to maintain the tests also goes up. And that's where our slowdown in effort starts happening. Okay. So that's just maintenance. Now it's also high effort to actually execute manual tests. And now the speed of delivery, let's see, speed of delivery means getting that software shipped. When the effort of executing the tests goes up, the speed of delivery goes down. The effort to maintain the test goes up, the speed of delivery will also go down. Both of those things are going to slow us up. Now let's add in test automation. So we have to, if we don't do test automation, if we do test automation, let's see how that changes this. And macro test automation isn't unit tests. These are other kinds of tests, like using WebDriver, Selenium WebDriver tests, or other ways of automating your UI tests. The problem with macro tests is they, as the number of tests go up, they will improve the quality, but they also still increase the effort to maintain. Micro tests or unit tests, as the number of micro tests increase, the quality will increase, and it will improve the speed of delivery. Look, there's no negative sign here. There's no minus sign. So by adding micro tests, we can improve the speed of delivery and quality, where if we just add large WebDriver tests, it only improves quality, but it will slow us down. So if we only do macro tests using WebDriver tests, we're going to have a problem. We're going to release slowly. But micro tests are small and they're and they can be maintained for years. So if you want to improve your software projects and get them up to a 5-star project or a 4-star project, you really want to focus on adding those micro tests. Okay, so I added a new aspect to this conversation. For TDD, test-driven development, we're really talking about micro testing. We're testing small functions, and by testing many small functions, we have simple tests that test simple things, and we have lots of them, and they execute quickly. Macro tests, Selenium WebDriver tests that go through UI, there's value to them too, but the problem is the feedback is slow. The time to get feedback to run those tests is slow. Of course, it's better than the past where we did only manual testing. And in order to do manual testing, you had to have a UI up and you had to have people operate the keyboard to make the test happen. And so because the speed of feedback was slow, it costs a lot of money to do very much testing. But with unit testing, we can have fast feedback. We can have lots of them. We can have it covered most of the code, and we could just have a few macro tests, the slow Selenium WebDriver tests. And I'm not saying don't have any Selenium WebDriver tests, but only having Selenium WebDriver tests is not going to be a good thing, because you're kind of looking like this area where you're going to have a more expensive number of tests, and you're going to have slow feedback. And now we lose all those effects of having good design, that the developers can change things quickly and get feedback on design. Now, one of the problems that adopting TDD has is if you on the call, if you are on a project that already has, say, 100,000 lines of code, maybe 1 million lines of code, you're thinking, my goodness, how am I going to start doing TDD when I have all of this existing legacy code? The first step is to think about and talk with your team and management about the problem and to commit to doing something about it. We won't be perfect. We can't change everything right away, but we can start making it better. How we can do that is we identify parts of the legacy code that we're always going to do TDD in. Maybe you do this at the beginning of the sprint. You look at the functionality, you go, oh, we're going to do these 5 user stories. Those 5 user stories are in these areas of the legacy code. We're going to do TDD in that area. Some of those functions will be easy to test and some of them will not. And sometimes you'll make a compromise. You'll add a unit test to some part of the code. Maybe the class has 5 public methods, but you add a test for 2 of them and some of them which is not. That's okay when you're getting started with a large legacy code base. You don't have to have everything all done with TDD because it's with a legacy code base, you have to catch up. You might have 10 years, you might be 10 years behind on doing testing. All right, so now if we're going to break code into chunks so we can add unit tests, that means we're going to have to refactor or redesign a little bit, but we don't have automation. How do we test that? If we change the design without automated tests, then we have to do it the old-fashioned way. We have to do some manual tests. My recommendation is if you have a function with about, say, 4 different conditions in it, maybe if something, else something, else something, else something, you say, oh, I need to change this first if condition. Then you put a breakpoint in there, refactor the code in that area, in that block, in that first if block, and then you use the breakpoint to identify when you're manual testing that you're going into that block. So you can watch the code execute and assure yourself that at least you're manual testing this refactoring. And that will take some time because it's not automated. But when you're done, you should be leaving behind some better design and some unit tests. And over time, you want to measure your code coverage so that every sprint, this goes back to your long-term plan, your rule could be every sprint, we always improve the code coverage. Maybe only a little bit, but we always improve it. And eventually you'll get there. And this has worked very well for me. Sunil, I'm going to take a break, and it's your turn.
Thanks, Lance. So yeah, hopefully you have seen, as Lance has shown uh, briefly, about how to practice, but also the benefits of test-driven development. You have seen that, and so now you are like, yay! I see the benefit. I want to practice it. Now what, right? And as I was saying earlier, practicing happens when there is effective adoption. So some of the key things that which we have seen for helping and being successful at adopting TDD is, when there is around 80% of adoption within the team, right? And consistently over a period of time, not just 3 months, 6 months, but consistently practicing test-driven development is successful adoption, right? And so for that, 5 key things that we've identified or is one is a clear understanding of the value of TDD, having measurable metrics, which you can actually effectively measure and to see how the benefit, the value it is deriving. Having 200% executive support and middle management support, because without top level support, often these adoption efforts fail. Having an clearly identified roadmap, which obviously will be iterative and change, but having a roadmap to begin with, which will help with the introduction and also scaling. And also developing a ecosystem which is interactive, immersive, and consistently engaging, because without this, the practice does not really work effectively, right? So having an ecosystem is very critical. Lance, 18. And in the interest of time, we'll briefly go over this, not too much detail, because we do want to have enough time for Q&A. Well, I'm sure you have lots of questions around this. So very briefly, like, having what a sustainable test-driven development adoption ecosystem would look like, right? Where you have, coaching and training, you have content, online content, offline content, you have social interactions, community of practice, blogs, SharePoint, etc. You have you're leveraging media, mobile apps, video learning channels, wikis, organizational changes, organizational interaction, onboarding checklists, job descriptions, MBOs, communication, leveraging communication, again, newsletters, ask me anything, webinars, those kind of things. Having gamification, contests, hackathons, and as I was saying, coaching and training, coach the coach, dojos, boot camps. These are all needed for an effective ecosystem, which will enable and sustain test-driven development. All right, Lance, 19. And now, and we want to share the success that some of the teams have seen, and you have to have, like, and you can see the measurable impact that is there, having test-driven development, CI/CD, shift left initiatives, all this together can come together to develop high quality code. Next slide. And as you can see, some of the results that we have seen, code coverage going from within a quarter, going from 45% to 85%, technical debt being virtually eliminated from 18 days to 3 days, and sometimes we have seen totally zero in a matter of a couple of months, right? You can see code coverage consistently going up quarter over quarter, as number of unit tests have been going up quarter over quarter, right? And we use Sonar Cube to address, to capture metrics, and you can see the issues with Sonar on Sonar Cube has been going down. The defect escape ratio and code quality, code quality increasing, defect escape rate going down, fallouts going down. So there's the results that we have, right? Lance, next one. So very briefly again who we are. So TDD Gurus is a community of TDD practitioners. It is not an organization in that sense. It's just a community of coaches, consultants, trainers, developers, quality engineers, uh, where we share thought leadership. We set practice standards, and we share that knowledge across the with others. So that is what TDD Gurus is planned around. We want to evangelize TDD practice and help organizations adopt this practice. That is where this webinar is also designed towards. Hopefully, as you see this and hear this, and then you go back to your own teams, you talk about the benefits, and you want to talk to leadership and say, we should practice this thing. If you're not already practicing, then we should practice this, and these are the benefits. And and you can be part of TDD Gurus, right? Or we can invite us, and we can talk about this. So our purpose is to maximize the value add to the client, uh, solve software quality issues, and reduce software related delays that are there. If we can develop higher quality code faster, then we can reduce the project carrying cost. So, and we can help with teams with agility, synergy, and having mutual responsibility with business and out within the technology team going together, right? So this is some of the who we are, and this is what we want to bring in. And Lance, the next one is for you.
Okay, I'm going to go ahead and pass on this one. This one's more about large organizational adoption.
Okay.
And I'm going to, try to tap it to the next slide. Here we are.
Okay, so
So
it's up to you.
here's something that I really recommend everyone to just try today after this webinar is go to codingstories.io. I'm going to type it into the chat and save this so you can find it later. And go give it a try. Give some of the lessons in here a try. Coding Stories, let's see if I have a window up on this, will show you how to, hang on a second. With Coding Stories, you can find different things to try out. Open and close principles, a clean code principle, and it will teach you open and closed by taking you through a story that shows you how to write the code for it. They'll also mention what language. This one's in C#. Coding Stories will have, I know there's one on Java for teaching mocking, and that's one that I've done. So if you go, I couldn't find it before our talk, but you can go in here and search through the different coding stories, and there'll be one that's called TDD TDD Hello World to Mocking. So it teaches you a little bit about TDD using a Hello World example, which quickly gets a little complicated. So you have to do some mocking to make the unit test work. All right, so that's something you can do right after this talk, and it's free. It won't cost you a cent. The other thing I wanted to share with you is I am setting up a TDD course in India time that starts at 6:30 p.m. to 9:30 p.m. India Standard Time, and it's over 2 days. It's 3 hours each day, so you won't be too tired, or I won't be too tired either. And we'll build a Spring microservice with a UI using TDD, and the cost is $100 in the India region. And all you need to do is you need to have a web browser that's relatively modern and good internet connection. And I will have a classroom in the cloud that will have a IDE for you to use. And we'll be using Git as well for source code control. And if you like Eclipse or IntelliJ, they're both there. So you get to choose which one you want. And then we'll work together building a Spring microservice. So this is a live class that I'll be a part of. All right. So the link to the class, by the way, is TDD Academy. And I'll type that into the comments. I would love to hear from people on this conference now. to either add to the chat questions and we'll answer them, or talk to us interactively, whichever you care.
Yeah, we would like to know as to some of the challenges which we have shared, are they indicative of what you have found? You have something different? And what are your thoughts?
Good. Okay. So participants, if you can type your questions on the chat. Meanwhile, I'm having some questions. Right. So many times, yeah, what you told is good, looks good, but at the same time, there is some questions related to that. Like as a developer, if you look at like a TDD way of doing a development, right? They most of the time feels like it's a reverse way to write code, because they are very much uh, tuned to write code first and then write something in the test case, or maybe somebody else will test that. So I understand we have talked about all those benefits, and they are also having some questions around that, like what will happen to that design, right? Should not we design first and then write code?
Right. The first thing when you write some code is you need to think about an interface. And to do TDD, you're thinking about the interface first, because in order to write a unit test, you have to talk to your code through an interface. And it does sound backwards, and it did feel backwards. When I did TDD, it was really different. But now the first step I do is I think about, okay, I'm going to write some functionality. If it's greenfield, brand new functionality, I need to put it somewhere. I need to put it in a class, and I need to put it into behind an interface. So at that point, instead of writing my class, let's call it, I'll just stick with hello world. So I have a hello world class, and I have a say hello method. But instead of writing that code, I'll write hello world test. So I'll make a test class, and I'll write a micro test that's called hello world say hello.
Okay.
Fact. And those coding stories, the TDD Hello World to mocking, will take you through the steps and help you help you through the part that feels weird, which is to write the test first.
Okay. Okay. And one more question that we keep hearing. One is like from the managers or from the developer also, that this way looks like I need more time to write code. So as a leader, I should ask my team to adopt, and then I have to give more time. Or as a developer,
Yeah.
I have to convince my leader to uh, get more time on that.
So yeah. So I think we have seen that, and that is a common myth actually. That is a common misperception that is there, and this comes up quite frequently. So it is that, like adopting any new practice, you have to learn that, and as you get better at it and you learn more about it, it becomes easier, and then you don't feel it anymore. It does not take any more additional cost. Initially you will find that, and as you start practicing, that it will take you maybe 10-15% extra time, but over a period of time, that is what we have seen, it does not add anymore, and that becomes the norm. That is how you work, right? So management has to be bought. That's why I mentioned that management has to be 200%. Initially they will see a lag, but over 2-3 quarters, they will start seeing that there is no more lag, there's no delay. And actually the team will be spending less time fixing bugs and deliver higher quality, so you'll not be seeing any loss of time anymore at that point of time, right? So that is the benefit that this will bring, and that is how your management can be brought over, and see the benefit of this whole adoption and practice.
For me,
Okay.
here's another thing I'd like to add to that. Is your management happy with their current bug count? Is their management happy with the inventory of bugs? If the inventory of bugs is always climbing up, are they worried about that? If they don't want to change anything, then it's difficult to change anything. But if they're not happy with one thing, you just need to figure out how to connect TDD to solving that one thing. And bug count's an easy thing to start reducing, but it will take some time to have the skill. It usually takes about, if your team goes at it pretty strongly, it would, in about 4 weeks, you will become pretty good at unit testing. And after about 8 weeks, you'll be close to the same speed you were before in developing features. But there will be an initial slowdown for the first 4 weeks. And then whenever you're learning anything new, it slows you down, whether you're doing TDD or you're learning a new framework.
Okay. Okay. Yeah. And one more question that we keep hearing, like anyway, you have touched upon a little bit on that line as well, but uh, people, most of the time, the developer also say that for them, adopting this is much easier when they are going for the greenfield. But most of the developers, they are struggling right now with the legacy code. And at that point of time, bringing this, how they will be able to use the TDD in brownfield or any of legacy code where they do not have enough safety net, or maybe that test cases, or maybe that lots of uh, stiffness is there in the code.
Okay. Yeah, so the first point is, since it's easier to do it in Greenfield app, oh my goodness, if you're management and you are a developer on a Greenfield app, start doing TDD, because you're just making a brownfield for somebody else, right? And it is a little harder to do TDD on a legacy application, brownfield. So to get started is work with your team to agree to start adding tests for some of the functionality they're doing every sprint. So if you're in your sprint, you're building 4 user stories. Let's say every user story, out of our 4 user stories, we add at least 1 unit test. And that will require some refactoring to make the code unit testable. Okay, and so if you have a lot of code, let me add a quick little file here. See if I can do this quickly.
And as Lance bringing it up, right? So we always have this, and we have been working on that leave the code better than you found it. So legacy code, right? You don't have to boil the ocean. You don't have to take everything up and start working on them. But even if whatever code you're working on, that which you can change, right? And that is where it becomes important, that just the lines of code that you're working on, refactor them, write your unit tests, refactor them, and make sure that you are leaving it better than you found it, right? So that is another thing for working on legacy code, and it's true. Legacy code is something which team developers consistently have to come up working against.
So just a quick point: if your goal is to write a unit test inside of this function, and I just imagine this pseudocode here, and this pseudocode is many, many lines long, more than fits on the screen, then you're going to have to make some choices. Hopefully, you can identify, oh, in my test, I need to change this block. Okay, great. The first step then is to extract that code and move it into a new method. So if we take this code out and we call it, let me call it old code. I'm going to use bad names right now because we don't have a real functionality here. So we're just going to call our old code, and we're going to have a new one up here, void public old code old, and we put our functionality in there. That's a refactoring you can do on most legacy code, and you'll need to do this one refactoring. See, it's just simple. I moved it into a separate function. So now I can say this code I'm going to build, I'm going to add my new functionality in here using TDD. And this code down here, I'm going to ignore it. Though I have to change one line. I have to call my old function. I have to call this new method that I added. And now I'm going to focus on writing a unit test for this. And so my next step then is to say, oh, I need to add a new test class. And now I'm going to call it legacy test. And I'm going to hit finish. And then I'm going to add my new test for that functionality. We called it public test old. That was right, old. And then there, we're going to call our old class. And we're going to build our test code in here. Okay. And we'll do that before we make any changes back here in our legacy code. So we'll get our test up and running. Put my voids where they belong. And we'll get this test up and running to get it to a red state that fails because I haven't made my code change in here yet. Okay, so that's a quick little example of how you extract some code, put it in a separate function, and then test it. And that's something I would do on a legacy application, not on a greenfield application. And then over time, this really giant function will turn into many smaller functions that are more testable. Does that make sense?
Yeah, definitely. Okay, so one more question, and then we'll see that if we are still getting some from the participants. So that is another question we keep hearing. The moment you will start talking about TDD, you will talk about refactoring and unit test cases. People will ask that, what should be the coverage?
Oh, I don't know, Sunil, what coverage do you like?
So coverage should not be the goal, but often that's true. People always look at, code coverage, and that becomes, you will get code coverage, and like 80%, they talk about 80%, 90% code coverage. But code coverage should not be the goal, right? It should be, the goal would be to deliver higher quality code with zero bugs. That should be the goal. Code coverage should be a good byproduct. But companies normally, which we have seen, set the expectation around 80%.
Yeah, I have seen that lots of time people say proudly that our coverage is this much, 80-85%, right? And yeah, I got your point, but why we should not focus on the coverage? What is the harm?
The harm is in that people start then writing unit tests after the fact also. They don't practice TDD. They just want to have a lot of unit tests. And writing unit tests after the fact, you have, and what we see and talk about is that you build this ineffective suite of tests. You're running this test, but they're not actually effective because you're writing a lot of this testing after the fact of, you're writing your code. So that is not helpful. One of the key parts is that, key aspects is that practicing TDD is that, or benefit of TDD, that you write tests before anything else, right? So
Yeah,
you might, right? So that is the the drawback. When you start looking at just the code coverage, then and we continue to see people write, oh, there's a mandate now that I have to have 80% code coverage, 85%. So I'm going to write a bunch of unit tests, but they don't actually do anything. They're there, they show, but they don't do anything, right?
Yeah, that's correct. Also true.
Yeah. So an example of this would be if I create this test, but I don't have any assertions. If you don't see an assertion in here,
yeah,
then you're building fake tests, but your code coverage will look good, which is a bad thing.
Or maybe you have just assert true at the end.
Right. Another one. Nice. Always passes.
Yeah.
That's nice.
That's where that's why sometimes we use the mutation testing also, right? Just to see that
Yes.
you are making any change in the code, but whether it's breaking anywhere or not. If it's not, that means you have to change your test cases, right?
Right.
So, yeah. Okay. Okay. Great. It was right. I feel that people have really enjoyed with this session, and they could have enlightened. Still, we are just trying to get more and more questions. Probably we will send you through the mail also those, and we will again sync up sometime back later also on that. And yeah, and nice to have you, Sunil, here, right? Because just now I got to know. Yeah, and nice meeting you.
Thank you for inviting. And yeah, so feel free to reach out to us, to Lance or me. You have the contact details. And any other questions, anything else, very happy to help. Again, we want to increase adoption of and practice of test-driven development. That is what we continue to strive. Thank you for the opportunity.
Definitely, yeah. Thanks,
Thanks,
Lance. Thanks, Sunil.
Thank you so much.
Yeah. Okay.
Thanks, everyone. I hope you enjoyed our talk.
Thank you.